So we want to sketch this. Now remember, we are focusing on the format of A times the absolute value of x minus h plus k. This helps us decide everywhere we're shifting. Now notice the A is negative. What does that mean for us if the A is negative?
Downward.
Good, it's opening down. So remember, if it's positive, it's smiling. If it's negative, it's opening down, it's frowning. Now, what does this look like? Is this a parabola? Is it a shooting star? What is it? It's the V, right? It's the V. So our parent graph looks something like this. We are centered at 0, 0, and it's a V. Sorry, because we're frowning, it looks like this, right? But now we're shifting this. So now we're shifting it based on our H. It's a -3, but be careful. If it's a -3, it's opposite of what your intuition is telling you. So we're not going to move it to the left 3. Where are we going to move that turning point? To the right 3. But now it's also +2. So we're moving to the right 3 and then what? Up 2. To the right 3 and then up 2. So I'm going to take this. I'm going to take this graph and I'm now going to the right 3, 1, 2, 3, and then up 2. And now here's my new turning point. Are we still frowning? Yeah, we're still frowning. So it looks something like that. Okay, somebody tell me, what is my domain here? Megan? All rails, you got it. Nico, how did we decide that?
Let me see. Because it's negative infinity, positive infinity.
Yeah, because of the arrows, right? The arrows are going left and right forever, so those are our infinities. All right, now let's talk about our range. What is our range? Matt?
Is it greater than or equal to 2?
Close. So we're definitely 2, but we're not greater than 2. That means everything's going up. So less than or equal to 2. You got it. Why such that y is less than or equal to 2? Because 2 is our highest point, but then everything's going below that. All right, let's shift the shooting star. Let's see what this looks like.
So if it wasn't like frowning, then it would be like y is greater than or equal to 2.
Exactly. You got it. Okay, how was I numbering these? B, C, B, okay. So now we're going to have y equals a times the square root of x minus h plus k. This is our shooting star. So the A is up or down. The H is our horizontal shift. and our K is the vertical shift. Similar to everything else we've been doing, right? So now our parent, well, let's just do an example. So let's sketch y is equal to the square root of x plus 4, and then outside that square root sign, minus 1.
What the A?
The a is just 1. There's nothing there, so it's a 1, which means it's positive, right? Okay, so what you do with this when you're sketching, you start off with visualizing your parent graph. So for the shooting star, the parent graph is starting at 0, 0, and it's sort of a shooting star going to the right. Do we all agree that's our parent graph? But now I have to shift this based on what we have. So let's write down underneath of it, we want x times the square root of x minus h plus k. So now I'm going to take my starting point here and I'm shifting it. It's supposed to be x minus h, but now it's x plus 4. Since it's plus 4, am I shifting to the right or am I shifting to the left? Left. So I'm going to take that, I'm going to shift it 4 units to the left. 1, 2, 3, 4. But I'm not done. Then I'm shifting my k. Am I going to go up 1 or down 1? Down 1. So we're right over here. My A is positive, so am I still shooting up towards the right? Yes. So it just looks something like, I don't know, like that. If you didn't want to cross, like if you just wanted to do like that, that's fine. As long as you show that you're up and going to the right, it doesn't matter. Like I said, this is just a rough estimate of what it would look like. It's not an exact graph.
My worst thing last year with doing this stuff was like, I had the points all right, but I just like something like that where you have to like show where it's going afterwards, like continue the shape of it. That's like where I was lost.
So last year you guys got to a point where it's a little bit more specific, right? Where you then had to find the x-intercept and the y-intercept. We're not doing that. This is just a general sketch. So as long as you know where the movement is going, you're good. All right, let's talk about domain and range here. Who thinks they know the domain? Aaron?
Greater than or equal to negative 4.
You got it. X is greater than or equal to negative 4. Who wants to try the range for me?
Y is greater than or equal to negative 1.
Perfect. Y is greater than or equal to negative 1. Anybody still confused with how we're figuring out the domain and range? Because it's not going away. Okay, so the domain, you know, is x, right? The horizontal. So what we do is we look at our shifted graph, not the parent graph. We look at our shifted graph and we're like, okay, what's the furthest left I go? Well, the furthest left I go is this point right here. So where does that line up with? X equals negative 4. So then that's the furthest left I go. Then I ask myself, well, what's the furthest right I go? So we're going from negative 4 all the way here, which is an arrow. What does that arrow mean? It's going on forever. So this is saying my smallest number is negative 4, and then I could go on forever. So that means it's greater than or equal to negative 4. Same idea with the y. So for the y, you look at your lowest point. My lowest point is right here, which corresponds to y equals negative 1. So now we're negative 1, and then I look, what's my highest point? Again, it's an arrow, meaning it's going on forever. So we're greater than or equal to negative 1. All right, let's do shifting for the disco dancer. Oh, actually, let's do, hold on, let's do one more example here with the shooting star. y equals negative root x minus 2.
Can I use the line?
Yes, could you do the pass?
Is it 30s?
Yeah. Okay, so now remember, this is a root x minus h plus k. So now is my shooting star going up or is it going down? It's going down because my a is negative. Now my 2, am I shifting left or am I shifting right? Right. Am I going up or down at all? No. So now we come up with our sketch. And I'm going to go right 2. So we were at 0, 0 for the parent graph. So then I'm moving right to the 2. I'm not moving up or down at all, but because the a is negative, instead of shooting up, I have to shoot down. All right, I'm going to just call on people for the domain and range. Ion, is that right? Ion, what's the domain?
Greater than or equal to 2.
Good. Greater than or equal to positive 2. Perfect. And Kiefer, what's my range?
Less than or equal to 0.
Perfect. All right, let's do the disco dancer. So y equals a, open up our parentheses, x minus h cubed plus k. Again, well, there's no opening up or down for this. I'll show you the different scenarios. So the h is the horizontal shift. And k is our vertical shift. Now, just to show you the parent graphs here, if we have y equals x to the third, it's like that kind of disco dancer, like 1 to 3. But if it's y equals negative x to the third, it's not 1 to 3 anymore. Now it's 2 to 4. So that's the a part of it. So if it's positive, it's the 1 to 3. If it's negative, it's the 2 to 4. Okay, let's do 2 different ones. My first example is going to be y equals x to the third minus 1. Is there a horizontal shift at all? How do I know there's no horizontal shift? How do I know my horizontal shift's not 1?
It's outside the parentheses.
Good, it's outside the parentheses. It's outside the parentheses, so there's no horizontal shift. So this is saying I'm taking my disco dancer and I'm just moving 1 down. I'm not shifting left or right at all. My a is positive, so that means we're 1 to 3. So it looks something like that. You go.
I actually have a question about the last one.
Like up here?
Yeah, I just, for the range, I don't, like, because I proved the domain, it was like x is greater than or equal to negative 2, but then the range is like y is less than or equal to 0. I just don't know.
Okay, so what's the lowest point here? What's my lowest point? Isn't it an arrow?
Yeah.
Which means negative infinity, right? So then you're like, okay, what's my highest point? My highest point is 0. So that means I'm anywhere below 0. So if you like the integral notation more, you could be like negative infinity to 0. Is that better? Do you like that better?
Do that?
Yeah, you guys can write any notation you want. I taught you both notations, remember that?
It's like 10 times easier.
Oh, is it?
Yeah.
Okay, if you like that, then go for it.
Alright.
That's why I taught you both notations. It's whatever you prefer. We good?
Wouldn't it be 0 to negative infinity?
No, it's always smallest to biggest.
Oh.
So our smallest is the negative infinity, and then we're ending at 0. If it were like 0 to positive infinity, it would be 0, comma, infinity, like that. Okay. Let's do another one of these. So the negation, open up your parentheses, x minus 1 cubed minus 2.
We never did the domain and range, right?
Oh, we didn't do domain and range. Sorry. Thank you. Let's go back. Let's do domain and range for the first example. Do you guys want me to write an interval notation? I could write interval. Both? Okay, I could write both. All right, what's the domain for this one?
I mean, for interval, it would be it would be parentheses, negative infinity, comma, infinity, parentheses.
Yep, perfect. So what is that the equivalent to? All real numbers. All right, what about the range? What about the range?
Would be all the numbers.
Again, it'd be all real numbers, which would be negative infinity to positive infinity. All right, let's go over here. Back to our next disco dancer. We're definitely shifting, right? Definitely shifting this. Because the A is negative, I'm not 1 and 4 anymore. Now I am 1 and 3. Now I'm 2 and 4. So we're sort of like turning the way the disco guy's dancing. So now we are x minus h. It's an x minus 1. So I'm shifting 1 unit to the right and 2 units where? So 1 unit to the right and 2 units down. So here's my turning point for my disco dancer. And now I'm the worst at drawing disco dancers.
I'm like figuring it out right now.
Yeah, I'm the worst, but it looks something like that.
So you don't actually have to draw it going into the different quadrants?
No, you don't have to draw it going into the different quadrants. You do not. Because the arrows mean it's going that way. Okay, the very last, do we need to talk about domain and range again? Isn't it still all reals?
Yeah, it's all.
All right, last one for shifting rules is the rectangular hyperbola. What are we up to? So E. Yes.
Can you stop the
I can't stop it. You can stop it though.
It's not like
It's not allowing you to stop. I'll stop it later because then it will stop my recording if I move from the screen. All right, so let's talk about the rectangular hyperbola. So we're going to have y equals 1 over x minus h plus k. I'm going to put a star. The shift is for the asymptotes. Oh, then I forgot the A. All right, let's do this. Let's do an example. Oh, sorry. What is H? No? Horizontal shift. Guys, give me something. Horizontal shift. K is the vertical shift. And A isn't about up or down. If you guys remember our parent graphs where we were like this. That was positive A. And then when it was negative A, you still had the same asymptote, but then we were just in different quadrants. So it looked like that. Okay, let's do an example. Y equals 1 over x plus 3 minus 2. Okay, now remember, I put a star. Our shifting is shifting the asymptotes. Our shifting is shifting the asymptotes. Now, our asymptotes for our parent graphs are the axes, the x equals 0 and y equals 0. But now I'm shifting. So this is usually the center where the two asymptotes cross. But I'm going to shift x minus h plus k. So now I'm going to shift 3 units to the left. 3 units to the left. 1, 2, 3. But also 2 units down. 1, 2. This is now my new center of the asymptote. Once you get your new center of the asymptote, what you're going to do is you're going to draw a dashed line through it vertically. And you're also going to draw a dashed line through it horizontally. Now, based on my new asymptotes, was my A positive or negative? Was my A positive or negative? It was positive. So now, are we 1 and 3 or 2 and 4?
1 and
because it's positive, it's 1 and 3. And there you are. All right, let's talk about domain and range here. In my opinion, interval notation for the rectangular hyperbola is the more difficult one, but it can be done. I'm going to do set notation first. So my domain for set notation is basically, the domain is everything except the asymptote, right? Because it's going left and right forever, but it never touches this. And what is the asymptote here? -1, -2, negative, was it -2? 3, -3. So in set notation, all you have to do is write x such that x does not equal -3. So it's basically everything except -3. That's our domain. That's what this is saying. But interval notation, there is a lot going on. So for interval notation, we're going from -infinity, right? We're going from -infinity all the way to -3. But -3 is not included because we can't touch -3. But then there's more. We don't stop there. Then it's going from -3 all the way to positive infinity. So then you write or. No, I didn't. Right? So look at our graph. We're looking only horizontal. What's the furthest left I go? I go arrows, which is -infinity, and then it goes all the way to where the asymptote is, right? That's -3. So we go from -infinity all the way to -3. But then we take a break. It doesn't stop forever because doesn't the graph then pick up again? So I'm saying I'm going from -infinity to -3. But then it's going from -3 all the way to infinity. The only thing that's not included is the -3, which brings us back to the top one. Just can't equal -3. Nico?
Why isn't it included -3?
Why isn't it included? Because if it were -3, our denominator would be 0, and that's undefined. If you have a denominator with 0, isn't that undefined? That's why it can never be -3. Range. Let's talk about the range. Once again, set notation is easier. Basically, the range is everything except what number? -2. Yep. So y is everything except y cannot equal -2. Anybody want to see interval notation for this? No? No? Okay, I'm going to give you ones to try on your own. Actually, let's have some people come up and teach how to do these. That'll be better. So we're going to have y equals x minus 1 quantity squared plus 5. What? It is. Come up and do it, Nico. Walk us through the class. Do you want to do it on this or this? My computer or this?
I don't know. Screen.
Okay, so then I just use an expo marker.
What do you mean? Like on the screen?
Yeah, and then
You
I
do
just
that?
erase it, yeah.
Is that not bad?
No, it's not bad. It erases.
Okay. Really? Oh, cool.
You didn't believe me?
No, it just sounds weird. Alright, so this is a parabola, so I'm just gonna draw the graph. Oh, it's not good at all. Okay. Like that. Alright, so, can you finish? So the A is positive because it's a 1, so we're gonna go like a U. It's positive. So inside the parentheses, that's the horizontal shift, so it's -1, so we're going to just go 1 to the right. So that's where our little dots, actually not yet, that's not yet. and then plus 5, so that's going up 5. So just so right 1, and then 1, 2, 3, 4, 5.
You want right 2.
Right. So,
There you go.
yeah. So we're there, and then we're just gonna go. Oh wow.
Perfect.
That's how it looks.
You got it. All right, domain and range.
Domain, alright. So, domain, should I do both or just interval or?
Oh no, whichever one you prefer.
Alright, I'm gonna just do interval then. So, I'm just gonna be. That's just like,
You got it.
yeah. I think it's the same deal.
So your domain is perfect, your range is not.
Okay.
So all real numbers means for the range, it's going up and down forever.
Oh, right.
Here, you could use the eraser.
So,
It's not negative infinity, positive infinity means up and down forever. So it's not.
so what would it be?
What is the lowest? It is going up forever, right?
Oh, it's supposed to be the 5?
Yeah.
Yeah.
And I like that you did the square bracket. Perfect. Okay. Erase. Good job. Let's do another one. The next one is going to be y equals parentheses x plus 4 cubed minus 1. Nico, pick somebody to do this one. Since nobody likes to volunteer for me.
No. Stephanos.
Yes, I love that choice. Stephanos, it is all you.
I need some help.
You have the class. They don't help me, but maybe they'll help you.
You need help this out before.
So first step, you have to make a graph, right?
Of course. Step 1.
I think it's very funny that nobody's using the lines.
I don't like that paper.
Yeah, it like kind of takes too long. And then the horizontal, is it plus 4?
It is plus 4, but it's supposed to be minus 4. So are you going left or right?
Left.
Left. Good.
One, two, three, 4. And then the vertical, is it this one?
Mm-hmm.
So I was kind of confused here. This is where I got stuck.
So you're left 4, and then the vertical is exactly how it looks. So if it's minus 1, then it's down 1. So you go left 4, then down 1. Yep. And then which one is this? Is this the parabola, the V,
Is it the disco?
It is the disco dancer. You got it.
So is it like that or no?
So no. So for the disco dancer, the way you do it is it's sort of a little bit more horizontal at that turning point. So it's more like.
Oh, so not as.
Yeah, like not so SE. All right, keep going. You did that. So now it's about domain and range.
Domain and range.
Yep.
So, I don't know how to do that bracket.
It's fine. Do your best. You got it.
Is it all real numbers?
It is all reals. Perfect.
How do I just go like?
2 R's. Yep. Perfect.
And then now the range is. Is it the same thing? 'Cause
It
it's
is the
starting
same.
Forever.
So it should be Y for range. Perfect. All right, Stefanos, pick somebody to do the next one.
Anyone want to go?
This is good.
Do you want me to erase it?
Oh, yeah.
You fans can't really see what's going on.
That's all right. I should have stopped recording. We're stopping after this.
Would it be a negative A?
Yep, that's a negative A.